Good morning, everybody, and thank you for joining me today. So today what we're going to do in this webinar is run through configuring an AI advisor using data streams inside XMPro. Before we do that, and before we jump in, it'll be good for us just to get an understanding of the different terminology that I'll be talking to. So what's the difference between an assistant and an advisor? Those are the key things that I'm looking to run through here. To do that, I'm going to break it down from an aspect perspective. We're going to touch on assistant and advisor side of things as well. If we focus on the aspect pieces, so breaking them down helps us to compare the two of these things a little bit easier. So what is the focus of an assistant? What's the focus of an advisor? What's their role, approach, some of the benefits, problem solving, how do you interact from the user's perspective, as well as some of the value proposition pieces as well. So when we're talking about an assistant, its focus is generally task and operations. Its decision support capabilities are immediate or practical. Its expertise level is broad and general knowledge. So user interactions generally direct or command-based, and its main value proposition, why do you want an assistant, is efficiency and convenience. When we transition this to an advisor, you'll notice that some of these aspects start changing. So again, what's the focus of an advisor? It's to give you expertise and some strategy. Some of the decision support there is high level and complex. One of the key benefits of an advisor is strategic insights. So we're moving away from just increasing productivity from an assistant to the more insights side of things with an advisor. The user interaction is a lot more consultative, so it's not so direct or command-based. It's more interactive, and you'll see the value proposition right at the bottom there. When we start talking around an advisor, we're really talking around informed decision making. So an assistant is there for efficiency and convenience. When we touch on an advisor, we're looking a lot more for informed decision making. So keep these in the back of the mind as we run through and configure and look at the different pieces of an AI advisor inside XMPro. If I break this down into, so where does this work with regards to what we do at XMPro? And there's essentially three main areas of decisions that can get made. So you generally start with decision support. That's your dashboards, your BI, condition monitoring typically falls in here. If we're looking at decision augmentation, this is where you are reaching out and you're looking for prescriptive recommendations, augmented information from an AI perspective or from other systems, closed loop feedback, etc. The last piece is around decision automation, where you have a human who is not so much in the loop, but on the loop and keeping an eye on the automation pieces that are happening here. The current shift, everyone is moving towards decision augmentation, and we see the future shift moving towards decision automation as well. So we're generally evolving and moving from an informant to a performant state. From an XMPro perspective, we cover the spectrum of all three. So we go from decision support to augmentation all the way to decision automation as well. What we're going to focus on today, though, is we're just going to focus on the decision augmentation piece, this piece in the middle over here. And how do we start bringing some of this AI capability, more specifically the AI advisor pieces, into this as well. How we see the AI and how it's working inside the operational landscape is it's changing the landscape, but it's also helping and move. So what do I mean by that? So currently at the moment, you have automation, so deterministic workflow tasks. You've also got AI assistance. So with the ChatGPT that's happened over the last year and continuing into this year, everyone's very familiar with having a conversation, getting a response, and doing something with that response. So AI assistant, more freestyle chat side of things as well. That eventually, if you remember the prior visual that I had when we start going towards the more autonomous on the far right, you start moving into the area of generative agents. So how do I have a goal-based single objective agent? That will in turn move into how do I have group goals? So how do I have an agent that looks after specific things? And then how do I have a supervisory role that actually helps direct them from an agent perspective? And then the last piece is how do we get to autonomous goal seeking? So self-organizing agents who don't necessarily need a directed supervisory role, but can self-organize amongst themselves and work out what they should be doing and how they should be interacting with the different systems as well. You'll see on the far left here, as you increase your automation capabilities and your AI capabilities as well, you go up, you start going into and touching different areas of the outcome pieces on the right here. So when you start looking at your task-based agentics all the way up to self-creating at the top. How do we translate this into what it is that we do for industrial operations? So you'll see at the bottom, I've still got the same items, automation, assistant. I'll come to the advisor, agents, and then multi-agent pieces as well. So I'll just build this up for it. So these are the different areas that you can actually interact with inside XMPro. Generic algorithms, bring your own models if you want to go towards the more what we would call traditional AI, machine learning models and algorithms. If you want to use some of the notebooks, we have done a prior webinar on this as well. So creating an end-to-end example using the XMPro notebook. So how do I go from the one area all the way through to the other area and make use of the notebooks to be able to do that. So that has been covered in a prior webinar. I encourage you to go and watch it if that is of interest. How do you start bringing in some of the large language pieces down here? And this is where we start transitioning into the AI advisor pieces versus just an AI assistant. Some of the other areas, when we start talking around AI and we start talking around advisors and assistants, the next thing that comes in that is trying to do obviously RAG or retrieval augmented generation on top of that. So how can the advisors be a lot smarter? How can they be trained as experts in what they are to be able to advise you correctly? A key thing here is also bringing your own LLM model. It's one thing to be able to talk and go to a ChatGPT or an Anthropic's Claude, but how can you actually control the model that you want to use? And then on the far right, you'll see some of the agentic stuff. We're not going to go into that as well today, but just to give you a full picture of all the different bits and pieces from an XMPro that you can actually utilize for your AI journey around industrial operations. Before we jump into the advisor, if I just touch the AI assistant. So from an AI assistant perspective, there are a few different pieces in XMPro where you can use an assistant. The first is around recommendations. So currently, the AI assistant that you see here is in beta, where you can have a discussion and a conversation with the assistant around the recommendations. And what that will allow you to do is to get some insights into the data as you trigger it. You can ask it various questions. It can group, sum it up. It can provide you information from a graph perspective. That's tabular. There's a lot of different options in there, but it is just an assistant. It just assists you to find some of the information that we're actually looking for. The second area where you can do that is inside data streams. Now, data streams are what sits underneath everything that you're looking at here. There are data streams behind the recommendations that you saw before. So the AI assistant has data streams sitting behind it. The data stream that you're looking at here is using an OpenAI assistant agent. Now, what the OpenAI assistant agent does is it allows you to interact and actually talk to an assistant that you have defined inside OpenAI's playground. Again, what you can do there is you can configure a specific set of prompts. You can create a specific set of tools that it has access to, and then you can call it. The challenge with that, though, is you don't really have a lot of control over fine-tuning the prompt outside of that environment. So outside of that environment, you have to just use what was published, which means if you don't have access, you can't adjust the prompt, you can't adjust the model you're looking at, you can't adjust any of the parameters. If that is your use case and you don't need to, then by all means, you can just drag the component in from the toolbox and actually just use it to talk to the OpenAI assistant from a cloud perspective there. When we start getting to the advisor though, there's a few elements that we are configured to bring this to life, so to speak. I'll run through them here and then I'll actually take you into an example for them as well. So the first is the result. So where do you see the AI advisor pieces? Where can an end user interact with them? And how do they visualize and see some of the data for that as well? The second piece is how can you change and define and edit some of the prompts that you're looking at? You want to be able to have fine-grained control over which model you're running. What are your prompts? How can you change them? How can you shape them? As we're going on the AI journey here and interacting with large language models, prompting is one of the key elements to make sure, am I getting the right information out that's relevant to what I'm asking? Or is it just going to start giving me incorrect information and hallucinating? The other benefit of creating an advisor is you can create these, what we call experts in specific areas. So I can have an expert in rotating equipment. I can have an expert in quality. I can have an expert in safety, which means by narrowing their scope, by narrowing their task focus, you help to minimize a lot of the hallucinations that they can have as well. If you keep it too generic and too broad, what you will find is they will start hallucinating, just like we do, and the results are not going to be what you're expecting. The third element to this is we're actually using recommendations. So we created a generic recommendation that we are tying to the data streams that allow me to push it and make it available to the first screen that you saw here, which was the actual an app. And last, but by definitely means most important piece here is how do I actually create this? So data streams underpin everything that we're looking at. So that is the information of where I get my data, run my models, and actually present it to the end users on the other side. So let's jump into an example and configure what I'm looking at over here. So the first piece of the puzzle is let's have a look at the data stream, and then I'll work backwards from there. When you look at this particular data stream, I'll draw your attention right down here to the actual the AI piece and what it's actually doing. So the stream, when it's running, is getting data coming from an endpoint. Now again, this endpoint can be anything. There are a lot of different listeners in here from a library perspective. So all you have to do is drag it on. If you don't want to use MQTT, you want to use OPC UA or a historian, by all means, you can do that as well. You'll see we're getting the prompt details in here. So we're reading the prompt details from a data source. This is coming out of SQL. Can it come out of a graph database? Yes. Can it come out of another system? Yes. Do you want to store your prompts in CSV flat files and read that in? You can do that as well. The key piece here is you want to be able to have a generic mechanism to get your prompt details in. The stream here is also using recommendations. So if I've triggered a recommendation for this particular asset, do I want to re-trigger one, or do I want to even pass the information to the model and have it run? No, I don't. The key thing to remember here is you don't want to push every single thing through at a speed of, every 1 second to a model, because models do take some time to run. If you're running this model in the cloud and you want to get the per second, you can achieve that. Yes, it's going to be costly. If you want to run this model locally, again, you can achieve that, but it's going to be costly in infrastructure costs. The reality of the use case here is to work out under what conditions do I actually want to pass this information to an advisor and get a response back. So what you'll see here is we've actually got a filter that says if there's already a recommendation for this asset that was triggered by this AI advisor, we actually don't want to pass anything to the model. We just ignore it because there's already a recommendation that's been triggered. If a recommendation has not been triggered, then we're going to pass it to the actual model that we're looking at here. It's going to evaluate what we're giving it, and it's going to give us the information, and we are then going to run a recommendation and update the recommendation. If I double click any of these, there's nothing weirdly complicated about this. The actual configuration will just walk you through what you're actually looking at here. It's the exact same data streams for those who have used these in the past that you're familiar with. All that we've got access to here is a new agent in the machine learning side of things. So you'll see here is an Azure OpenAI. I'll scroll a bit further down. Here is a Llama agent. There is the OpenAI assistant. So all there are new agents in the actual library that you can just use in the same way that you are used to in the past. If I double click the SQL that I've got here, you can see we're looking at the prompt. If I double click this here, this is actually pointing to a local model. You have a few different options when it comes to how do I want to configure an AI advisor. As I mentioned earlier, I can go and push this to an AI assistant in OpenAI, where you can train as an expert, get the results that come back, and then add all the different other recommendations around that, and then you can get a AI advisor piece coming out of that. The challenge with talking to the cloud ones is there is a cost around the tokens. So it does not matter how many tokens you send, there is a cost to compute that and get the results for that to come back. The other option is you can run models locally. So this is actually running locally in the lab that I have set up here. And I can pass the URL of the model in dynamically. I can also pass all the system prompt and the user prompts in dynamically as well. If I want to change out, it's actually pretty quick and easy for me to do that. If I want to adjust, for instance, model temperature, I can adjust that as well. When the stream is running, the telemetry details coming in here will send our information through. What you'll notice here is I have a pre-filter. So what I'm looking for is I'm only looking for assets that have gone over and above or below certain thresholds that I've defined. I don't want to use the LLM to actually filter out noise. I actually want to filter out the noise before I get to, should I pass this to a large language model for it to evaluate further? Otherwise, you are going to just be wasting resources down here and passing it noise and hoping it figures out some of the pieces as well. Can you do that? You can. Again, you're going to have to take into account token costs if this is going into the cloud, or you're going to have to take into account compute costs from an infrastructure perspective locally if you're running a local one. So this is what sits underneath the hood. Data is coming in. We're getting some prompts. We're also using the recommendations to help weed out before we get to run the actual model itself. The result, where do I actually see the result of this? If I look at a particular app that I've got over here, it's the same app that we're used to and have been looking at in the past. On the right, you'll see here are the recommendations. If I click the top recommendation, this will open up a recommendation that was triggered by the AI advisor. So this is the result of that data stream that I'm looking at here. You'll see in the middle piece here, AI response. This is what the actual large language model gave me when it ran through this particular data stream and triggered a recommendation here. So again, this is how an end user can interact with it. If we go back one more step, so I've got a data stream. The data stream was actually triggering a recommendation. So if we go into, well, what does that recommendation look like? Exactly the same as you're used to. We have our recommendations. You will see they are configured and set to a particular data stream. So it's exactly the same data stream that we are looking at here. And we have created a generic recommendation for it. You still got access to all the detail and value. So I can be a lot more specific in the headlines and the descriptions with the data that is passing through the data stream as well. So exactly the same behavior you're used to when you're configuring recommendations for other use cases. This is just using it from a generic perspective to create an AI advisor that I can use on the apps themselves. If we go back to the app, this is a recommendation. If I go back one, you will see it'll take me back to the application itself, and I've got access to all my other recommendations. Now, for those who are familiar with some recommendations, this may look a little bit different. This is a recommendation with a different template that was applied to it. You can still use the prior recommendations if that is where you want to put all of this, but you don't have to. You can adjust the visuals to other types of visualizations for the same set of data. So here, I still have my event data as you're used to. I'll scroll a bit further down. I'll still have my analytics. I can still have my notes coming in here as well. Across the top, you can assign it false positive or resolve the recommendation as well. So exactly the same capability, presented a little bit differently. This is the recommendation that triggered for it. If we go back to the stream, that gets used down here. The recommendation that is triggered gets read in here, which stops me from talking to the model too many times. Let's have a look at the prompt over here though. So if I have a look at the prompt, you'll see it's coming from SQL. There is an actual application that you can configure on top of that as well. If you already have a prompt library and you just want to read that in, we can do that as well. This one, pretty simple and straightforward. What model am I looking to run? What's my model temperature? What is my system context for that? And what's my user context? System context defines that you are an expert in whatever. For this example, it's rotating equipment, so he's an expert in the pump efficiency and optimization. You can create an expert, as I mentioned earlier, from a safety perspective, from a quality perspective. Maybe there's some static equipment or different types of rotating equipment. You can also create an expert in the process flow. So let's take a manufacturing example. You can create an expert in the actual flow all the way from start of manufacturing to the end of manufacturing as well. User content is as you are used to when you are creating your own conversations with your GPTs. Which pieces do we actually want to plug in when we are running this through the stream? So when we say user content here, what we're actually meaning is, in this instance, the user content will actually be coming from whatever source of data it is. There's no actual user as a human that is sitting and talking to this. Your machines are actually talking to it in this example. Can this read from a human? Yes, it can. If you want to actually expand the AI assistant that I mentioned earlier with the recommendations and actually have a human ask similar questions, you can do that as well. So we're getting in the prompt details, and if you have a look at how they have been defined, AI assistant with an expertise. What is your task that you are looking to do, and what should you be considering? Depending on which model I want to talk to, I may want to change into my system prompts. I may want to change into my user prompts. I can do that quite easily over here, save the changes, and whatever the interval is that we've defined here. So if I go back in here and have a look, every 5 minutes, it will get the new prompt. If I want to change this and say, you know what, I'm actually trying to split test some prompts, I can change that to every 5 seconds as an example, which means if I save my new prompt details away, I just need to wait 5 seconds, and then it'll load in the new prompts, and I can then evaluate that. I don't need to stop and start a stream. I don't need to stop and start and publish anything. I can use an interface like this just to update and change what I'm looking at. The benefit of running a local offline repository like Olama is I could have one prompt that is using an Olama. You'll see I have another prompt here using SQL Coder as a model, etc. So I can have different models running for different types of assets, for different use cases, all running within the same structure that I've got defined here. So this is the prompt that is sitting behind and it's being fed into the data stream. This is the recommendation that we've configured and set up that I can interact with. And from an end user, this is how they can consume and react to the responses coming in. Now, some key things here is it's always good to make sure that you have a mechanism to give feedback to the model as well. Is this a good response or a bad response for it? So it can also help learn that the next time it runs through, it takes that into account as well. If I'm looking at this and I actually want to have a conversation to it, can I do that as well? Yes, you can. You'll see on the right here, I can start having a conversation and it can take into account this response. It can take into account the event data and my horrible spelling as well. So information in the middle, how we got that? We got that through the data stream triggering that recommendation there. This model was actually coming off of a local model where over here, as this is running, this is actually talking to a chat GPT. I think this is running chat 4.0, and I can have conversations with it with different data. Again, prompts, as you can move these around, the data, as you can move them around. All we're doing here is we're just putting the different pieces together around a use case that we call as an AI advisor on the data that is coming in. Some of the information that you're looking at in here as well, you can see some of the citations coming in as well. So again, grounded in where's my information coming from so that I can trust the data as well. So what did we just go through? From an AI advisor perspective, there's a few different elements to consider here. The first is the visual. Where can I consume the data? Can we pass this AI response to other systems? Yes, we can. This is just an example inside XMPro. We can pass this to any downstream system that requires it, needs it, or wants it. The next piece is the actual prompts themselves. How do I create the prompts, change the prompts? Maybe I want to do some prompt chaining in here. How do I tune the prompts for the situation that I'm creating or want to help manage? If we go one step further, the generic recommendation. So here we're just using our recommendation engine and creating a generic recommendation for the AI side. Can you be more specific and actually create recommendations for specific asset classes? Yes, you can. Can you hook this into existing data streams that you may have defined? You can do that as well. This does not have to stand on its own. It fits in with everything that you're used to and have configured up to now as well. And then the last is the data stream. So what sits behind this? What is actually consuming the data, bringing the prompts in, reading recommendations, passing it to the model, getting the result, and then passing that to the recommendation so that they can be triggered as well. The last slide I'll leave you with is, again, what are all the different pieces when it comes to the AI side of things for industrial operations? There's generic algorithms. You can bring your own model if you want to do just simple regression, etc. There is notebook capability, and as I mentioned earlier, there is a webinar that we have done previously, which will walk you end to end through that as well. This is where we start getting into some of the large language models. So there are agents for instance, Olama to run it locally. There are some to run OpenAI, and that library is expanding as more models become available. On the far right, when we start dealing with the advisor side of things, how do we do that on top of XMPro recommendations? How do we also start doing that on top of your own documentation as well? So how can we perform RAG, which again is retrieval augmented generation, on top of your own data? So we want to use your own data, your own manuals, etc., as part of that advisory capability, and then bring your own model. Maybe you've defined your own model and you don't want to use one of the available ones out there. You can bring that in as well. And just some of the other future work that we are working on right now is around the agent side of things. So how do you create a generative agent, a directive agent, and also moving towards multi-agent systems where they are self-organizing as well. And with that, I thank you for the time today. Thank you for listening to today's webinar. Hope you have a great rest of the day, and we'll see you again on one of our future webinars. Thank you.